slight camera malfunction on the last one. I just knocked it. So what was I saying? So they try and catch you out because they don't look parallel, because we know that they shouldn't meet, but they don't look parallel. But because of these properties here, so we've got 92, 88, 92, 88 with parallel lines. Let me just quickly recap parallel lines. If you've got parallel lines, say for example, because obviously this is where the trapezium could come in, so if this is a trapezium, you can check for properties of the parallel lines, because there is something where you've got allied angles where these two, they're the allied or co-interior. The co-interior make 180 degrees, and if that is true, then obviously if it's working on here, then they must be parallel lines. So obviously that works on the reverse as well, this pair here and that pair there. If they equal 180, they will be allied and they will be parallel. So obviously in terms of, in our diagram, we can see we've got 92, 88, 92, 88. So we've got these two pairs adding up to 180, so it must be parallel. So it is important that we do know some of our kind of facts with parallel lines. So because I know it, obviously I can answer that question. A, B, C, D is a trapezium. True. And the reason is allied angles equal 180, and I can see B, A, C, so B to A to C, so I'm just talking about this angle here, so B to A to C is 92, and then A to D to C equals 88. 92 and 88 equal 180. Allied angles equal 180 degrees. BAC is equal to 92, ACD is equal to 88, and we can see it on the reverse. So the examiner will be confident that I know what I'm talking about with that one. And then the final one to end it on is DE is tangent to the circle. So here is our DE, and if it's tangent, if we've got tangent to a circle, it meets it at 90 degrees. So if we look at that, it would meet a radius at 90 degrees. So if we think about that one, there wouldn't be a radius on our question, because obviously we know that isn't the diameter, so we can't use that particular fact. So we can't use the fact about the radius meets tangent at 90 because we don't have a radius. So the only other thing we can have a look for is the alternate segment. So the way the alternate segment works, if this, let's try and get this one. If this 32 degrees is in this segment here, and when I'm splitting this into a segment, I'm talking about this line here is cutting it into a little segment here. Then we need to find the alternate segment, so where this line, so that's our point there and there, it makes 32 in this side, but if we go over the other side here, we're saying is this 32 on this side. So if we can work out what this is, if it is 32, then yes, it must be a tangent. If it's not 32, then it can't be. So how can we work out if that is 32 or not? Well, we can see it's split into a triangle. So we can check it. If we've got 88 there and 50 there, what is the missing angle in the actual triangle? So 88 plus 50, oh, my calculator's not on, 88 plus 50 is 138. And we need to do 180 minus 138. 180 minus that would give us 42. So if it was a tangent here, then a tangent with the alternate segment, that should have been 32 because it's 32 there, 32 there, but it's 42 in the question, so that can't be a tangent. So D is a tangent to the circle. It's got to be false, and the reason being, let's talk about that angle. So it's from C to A to D, so it's this little one, C to A to D. So CAD equals 42 degrees. Angles in a triangle. However, if it was a tangent, it should be 32. So just try and write as much as you can about what it is, what it should be, and what it is if it's not. Okay? And that's it, I think, for that question.